Hello friends, welcome to H2 Event Academy. In the last lecture, we have discussed about the micro topics of the statics module. Okay, so let us discuss the topics further. So we have parallelogram law of forces. Okay, so let us read the statement. So we have, if two forces acting at a point be represented in magnitude and direction by sides of a parallelogram, okay, drawn from one of its angular points, their resultant is represented both in direction by diagonal of the parallelogram passing through that angular point. Okay, so we have two forces. Okay, so let us consider these forces as, this is P and this is Q. Two forces. Okay, this is our angular point. Okay, so if two forces acting at a point be represented in magnitude and direction by two sides of a parallelogram. Okay, so let us complete the parallelogram. So that this is Q. Let us draw a line parallel to Q. Okay, and let us draw a line parallel to P. Okay, so let us name this. This is O, this is A, this is B, and this is C. Okay, so now we have the parallelogram as OACB. This is our parallelogram. Okay, so we have, what we have to show is that this resultant R is the diagonal of this parallelogram. Resultant R is represented in magnitude and direction by diagonal of the parallelogram. Let us draw the diagonal. Okay, this is diagonal. Okay, so we have OA vector as, OA vector is P, OA vector is P. Okay, and we have OB vector as Q. Okay, and we have the OC vector is equal to R. समझ में आ रहा है? This is actually P vector, Q vector and R vector. Okay, and we have the magnitude and direction. Okay, so the magnitude is similar to this side of the parallelogram. So we have OA is equal to magnitude of P is equal to P. Let us represent this. So OA is equal to P and OB is equal to Q. Similarly, OC is equal to R. Okay, so we have considered P, Q and R as magnitudes of forces P, Q and R respectively. Okay, now let us apply the vector theorem. Okay, so we have OC vector as, OC vector is equal to OA vector plus AC vector. This is OA vector and this is AC vector. Okay, AC vector we can write as OB vector. So this is equal to OA vector plus OB vector. So we have OC. So we have OC as R vector. So R vector is equal to OA vector is P vector plus OB vector is Q vector. Okay, now let us take the magnitude as, okay, so let us take the magnitude, taking magnitude, or else we can take the dot product. Okay, let us take the dot product. So we have, let us take the dot product. R vector dot R vector is equal to P vector plus Q vector dot P vector plus Q vector. So this we can represent as P square plus Q square plus 2 times of P dot Q. Okay, this is P vector and Q vector. So we have R dot R is R square. So we have R square is equal to, sorry, let us further simplify this. So we have R square is equal to P square plus Q square plus, let us expand this. So we have 2 times of magnitude of p vector is p. So this is pq into angle between p and q. So we have angle between p and q. Let us consider this as alpha. This is 2pq cos alpha. So this is alpha, then this is also alpha. Okay, now let us drop perpendicular from here. Let us name this point as D. Okay. So now this is r square is equal to p square plus q square plus 2pq cos alpha, where alpha is angle between p and q. Okay. So now if let us take the case 1. So before proceeding to the cases, let us discuss that if angle between resultant and p is theta. Okay, if this angle is theta. Okay, so if r resultant r makes an angle theta with p. Okay, then we have tan of theta. Tan of theta is equal to CD upon OD. This is equal to CD upon, this is CD. So CD upon OD we can write as OP plus, sorry, this is OA. This is A and this is D. So this is OA plus AD. OD is equal to OA plus AD. OD, this whole length is equal to OA plus AD. This is OA plus AD. Okay. So CD is equal to, this is Q. Okay, so this is Q sine alpha. This is Q sine alpha upon OA. OA is P. This is P plus AD. AD is Q cos alpha. Q cos alpha. So we have tan theta is equal to Q sine alpha upon P plus Q cos alpha. Okay. So we have the resultant is given by, let us name this as 1 and this as 2. Okay. So we have magnitude of resultant R is magnitude of resultant R and direction theta is given by equation 1 and 2. Okay, let us discuss about the cases. So we have, let us write down once again. So we have the resultant R as, so we have two forces, this is P and this is Q. Okay, and we have the resultant R. Okay, an angle between P and Q is alpha. So we have the resultant R is given by R square is equal to P square plus Q square plus 2pq cos of angle between P and Q, that is alpha. Okay, now let us consider this angle as theta. So we have, let us complete this parallelogram. Okay, so this is theta. Okay, this is Q, so this is also Q. Let us take this as, so this is theta, so this is also theta. Sorry, this is theta and this is alpha, so this is also alpha. Okay, so this is Q sine alpha and this is Q cos alpha, this distance, and this distance is P. Okay, so we have tan of theta is equal to this one, Q sine alpha upon this is P plus Q cos alpha, P plus Q cos alpha. Okay, so the magnitude and direction of this R, resultant R, is given by this particular expression. Okay, so we have the case 1 as case 1. Okay, so if alpha is equal to 90 degree, okay, so we have p as p in this particular direction and q is in this particular direction. So this is alpha is equal to 90 degree. Okay, so if alpha is 90 degree, cos of 90 is 0. So from here we have r square is equal to p square plus q square. So from here we have r is equal to under root of p square plus q square. Okay, and we have tan theta is equal to, so we have alpha is 90, so cos of 90 is 0 and sine of 90 is 1. So we have uh, theta is equal to tan inverse of q times of sine 90 upon p plus q times of cos 90. So this is equal to tan inverse of, this is q upon p. Okay, now we have case 2. Okay, so from here, so r is greatest when alpha is equal to 0 degree. So if p and q are is in same direction, this is p and this is q, so alpha is equal to 0. So alpha is 0, then we have alpha is equal to 0, then we have cos of 0 degree is equal to 1. So from here r square is equal to p square plus q square plus 2pq. Cos of 0 is 1. Okay, so from here r square is equal to p plus q ka whole square. So from here r is equal to p plus q. Okay, and when r is minimum, so r is minimum when, let us take this as case 3. Case 3. Okay, r is minimum when alpha is equal to pi. This means p is in this particular direction and q is in this particular direction and alpha is equal to pi. So we have r square is equal to p square plus q square plus 2pq cos of pi. So from here r square is equal to p square plus q square minus of 2pq. So from r is here we have r square is equal to p minus q whole square. Let us further simplify this. R is equal to p minus q. This is our resultant. Okay, so let us discuss the next topic. Okay, so now let us discuss Lami's theorem. Okay, so we have, if three forces acting on a particle keep it in equilibrium, each is proportional to the sine of angle between the other two. Okay, so let us consider three forces. Okay, so we have this as P, this is Q and this is R. Okay, so let us consider the angle as, this is alpha, this is beta, this is gamma. So what is Lami's theorem? How we can represent this Lami's theorem? Okay, so if P, Q and R are in equilibrium, then we have sine alpha upon P, sine alpha upon P is equal to sine beta upon Q, sine beta upon Q is equal to sine gamma upon R. This is sine gamma upon R. Okay, so each is proportional to, if three forces acting on a particle keep it in equilibrium, each is proportional to the sine of angle between other two. So let us take this as K. Okay, so let us equate this. So we have sine alpha is equal to K times of P. This means P is proportional to sine alpha. Similarly, using this, we have Q is proportional to sine beta. Similarly, using this, we have R is proportional to sine gamma. Okay, so this means alpha is angle between alpha is angle between Q and R. Okay, so let us read the statement once again. So we have, each is proportional to the sine of angle between the other two. Okay, so we have taken P, so other two are Q and R. We have taken here Q, so other two are P and R. So beta is angle between beta is angle between P and R. Similarly, sine gamma. Okay, so sine, so we have gamma is angle between P and Q. Okay, so now let us prove this. How we can prove this? So we have forces as this is P, this is Q, this is R. Okay, so this is alpha, this is beta, this is gamma. Okay, so we have so in the statement it is given that if three forces acting on a particle, keep it in equilibrium. Okay, so let us consider. So we have let P, Q and R acting at point, let us take this as point O. Point O be in equilibrium. Okay, then P plus Q plus R is equal to 0. Obviously, let us take the cross product with R of this expression with R. So we have R cross P plus Q plus R. Okay, this is equal to 0. So R cross 0 is 0. Let us take this as equation 1. Okay, so we have R cross P plus R cross Q plus R cross R is equal to 0. Okay, so we have R cross P is equal to minus of R cross Q. This we can write as Q cross R. Okay, so we have R cross P is equal to Q cross R. So let us take this as equation 2. Okay, so now again let us take the cross product with P. So we have P cross P plus Q plus R is equal to 0. So we have P cross P is equal to 0. P cross P is 0. So we are left with P cross Q plus P cross R. Okay, this is equal to 0. So we have P cross Q is equal to minus of P cross R, and this is equal to R cross P. Okay, so here we have P cross Q is equal to R cross P. Okay, so this is equation 3. Okay, so now from equation 2 and 3, we have P cross Q is equal to R cross P is equal to Q cross R. So this is equal to Q cross R is equal to R cross P. Okay, so let us expand this expression. Okay, so we have, let us write this again. So we have P cross Q is equal to Q cross R is equal to R cross P. Okay, so let us take the magnitude, taking magnitude. Okay, so we have P cross R magnitude, P cross Q, this is equal to Q cross R magnitude is equal to magnitude of R cross P. So this is equal to PQ sine of, okay, sine of angle between P and Q, sine of angle between P and Q is equal to QR sine of angle between Q and R is equal to RP sine of angle between R and P. Okay, now let us divide throughout by PQR. So from here we have, if we divide throughout by PQR, 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 so we have sine of PQ upon this is upon R is equal to sine of QR upon this is P is equal to, here RP gets cancelled, R and P, so this is sine of RP upon this is Q. Okay, so we have considered this as, this is P, this is Q and this is R. Okay, so angle between P and Q. Okay, let us rearrange this. Rearranging all this expression, we have sine of QR upon P. Angle QR is, this is angle between Q and R. Okay, is equal to sine of RP. This is angle between, this is RP, this one is angle between R and P. So this is RP upon Q. This is sine of PQ upon R. Okay, let us further simplify this. So we have, this is QR. angle between Q and R. This we have taken as alpha. So this is alpha, and this is RP. So R and P, this we have taken as beta. So this is beta, and this is PQ. PQ is this we have taken as gamma. This is gamma. So we have sine of alpha upon P is equal to sine of beta upon Q is equal to sine of gamma upon R. Okay, so we have each is proportional to, so the forces are proportional to angle between other two. Okay, so let us discuss further. Let us discuss next topic. Okay, so we have the next topic as polygon of forces. So let us read the statement. So if any number of forces acting on a particle be represented in magnitude and direction by the sides of a closed polygon taken in order, the forces shall be in equilibrium. Okay, let us consider six forces. Okay, six forces as F1, F2, F3, F4, F5 and F6. Okay, let us assume the direction as, let us consider the F1 in this particular direction, F1, this is F2, this is F3, this is F4, this is F5, this is F6. Okay, so if any number of forces acting on a particle, this is our particle, this is our particle, be represented in magnitude and direction by sides of a closed polygon, okay, taken in order, the forces shall be in equilibrium. Okay, let us plot this. So we have F1, so let us draw the F1 in this particular direction. This is F1. Okay, let us name this as A and this is B. We have F2. F2 is in this particular direction, so this is F2. Now we have F3. This is F3. Let us name this as A, B, C and this is D. Now we have F4. So this is F4. Okay, now we have F5. Now we have F6. Okay, so we have A, B, C, D, this is E, this is F. Okay, so this is six-sided. We have represented this set of forces in six-sided closed polygon. Okay, then we can say that the forces are in equilibrium. Okay, so in the next lecture we will discuss about the problems. Okay, thank you.